In this video, we are starting chapter 12 with a review of circles and then a definition of tangent lines, what it means to be tangent. So let's just review what a minor arc is. The minor arc, or the measure of a minor arc, is the measure of its central angle. So a minor arc is always the smaller of the two angles that could be formed. So the minor arc here is going to be arc AB, and it would be the measure of this angle right here. The major arc is the bigger of the two angles formed. So if I wanted to say what's the measure of minor arc AB, I would look at the yellow. But if I wanted to say what is the measure of the major arc AB, I would look at the red. And the way that you would calculate it is you would just subtract 360 minus the measure of the minor arc, which is the yellow arc. A semicircle is half a circle, and since a whole circle has 360 degrees, a semicircle has a measure of 180 degrees. Arc length is this length right here. Right? How far would it be if you had to walk that distance? And in order to calculate that, you need the radius of the circle and you need the measure of the minor arc. So the formula would be measure of the arc over 360 times 2 pi r. And then a tangent line. What is a tangent line? It is a line such that it intersects the circle in exactly one place. And if we drew a radius to the point of tangency, that radius would be perpendicular to the tangent line. All right, so the tangent line only touches the circle in exactly one point and is perpendicular to the radius at the point of tangency. Here's your point of tangency right there. All right, so we also have a postulate here that says if a line is perpendicular to a radius at the endpoint on a circle, then the line is tangent. We also have a second postulate here. It says if two tangents to a circle share a common endpoint outside the circle, they are congruent. So what does that mean? Well, let's take a look at this. Here's the endpoint outside the circle. If I drew another tangent line from that point, then I would know that this segment is congruent to that segment. They start at the same endpoint outside the circle. They are both tangent to the circle, so the tangent segments are congruent. All right, so let's walk through some problems. Very first one, I give you a circle here. There's a couple of arc or central angle measures that are missing. So let's go ahead. I like to start off by first finding those central angles. So I know all the way around here is 180 degrees. So if I add up all of those, CG is missing. So if I just add up all of those, 45 degrees plus the measure of CG plus 67 plus 35, that should equal 180 degrees. So I know 35 and 45 is 80 plus 67 plus CG equals 180 degrees. So that's 147 degrees plus CG is 180 degrees. So when I find CG, I get 33 degrees. So this is 33 degrees. So this one right here, DE, has a nice right angle in it, so that's definitely 90. So how am I going to find O? Well, O is going to be, if I do the same thing, but go in the opposite direction, D to A, I know that 90 plus 30 plus AF equals 180. So 120 plus AF equals 180. So AF is going to equal 60 degrees. So this is 60 degrees. All right, so let's go ahead and answer the questions here. So it says, what is the measure of arc BD? This is going to be the minor arc, the smaller arc. So we're going to start from B and go around the circle this way and just add up all those numbers. So the measure is going to be 45 degrees plus 33 degrees plus 67 degrees. So I get 78 degrees plus 67 degrees. So that is going to be 145 degrees. So how about DFA? Well, when we have three letters, we have to follow in the exact order that they're given. So I have to go from D to F to A in the same direction. So here's D, here's F, here's A. So I know I'm going this way. So this is a semicircle. So I know its measure is going to be 180 degrees. How about arc GC? Well, we have arc GC right here, and we've already calculated its value. We calculated it right here. So we can say this is 33 degrees. And now we need to find the measure of arc DBF. Okay, so this is, we're going to go D, B, F in the same direction. We can't change directions, so we're going to add up all of those arcs there. So we have 45 degrees plus 33 degrees plus 67 degrees plus 35 degrees plus 60 degrees. And if I add up the first four, that's a semicircle, so that's 180 degrees plus 60 degrees, so I get 240 degrees. Okay, so now we have to find arc length GD, and I believe the example gave us a radius of, let's use a radius of 60. Okay, so let's say the radius of the circle is 60 inches. Okay, so GD has an arc measure of 45 degrees. So in our formula, we take the central angle of GD, 45 degrees, we put it over 360 degrees, and then we multiply that by 2 times the radius, which is 60. So I like to do this. It makes it a lot easier. And then 2 goes into 6 3 times. So now we have 45 pi over 3. And then I know 3 goes into 45 15 times. So I have an arc length of 15 pi inches. How about GBA, the arc length of GBA? Well, GBA starts here, and I have to go in the correct order, and I can't switch directions all the way over there. So what is the measure of that arc? Well, it's 33 degrees plus 67 degrees plus 35 degrees. We're going to divide that by 360 degrees, and we're going to multiply that by 2 pi, and your radius is 60. So again, I'm going to reduce that, and I'm going to reduce this, and I'm going to add all those up. So 33 and 67 is 100. 135 is 135 pi over 3. And then when I divide that out, I get 45 pi inches. All right. So let's move on to the next example. Here it says we need to find the value of x. Oh, I forgot to write the x in this one here. All right, so we need to find the value of x. And all lines that look like they're tangent are tangent to the circle. So I know that LM is tangent to my circle and MN is tangent. And one of the properties of tangent lines is that they're perpendicular to the radius at the point of tangency. So I know that I have a 90-degree angle here and a 90-degree angle here and 117 degrees. And I know for a quadrilateral, right, a four-sided figure, L, right, these four sides, I know that the angle measures should add up to 360. So I get 90 plus 117 plus 90 plus x equals 360 degrees. So I get 180 plus 117 plus x is 360 degrees. So I get 297 degrees plus x is 360 degrees. So I end up with 63 degrees for x. Okay, so how about in this next circle here? Well, I see that DE is a tangent. So I know that it is perpendicular to the radius at the point of tangency. So that just makes this a nice right triangle. And I know the inside angles of a triangle add up to 180. So I have 90 degrees plus 38 degrees plus x degrees equals 180 degrees. So that's 128 degrees plus x degrees equals 180 degrees. So when I subtract these two, I'm going to get 52 degrees for x. All right, so let's see, how about here? We're solving for x here. All right, so for this one, this looks a little bit different. Okay, so I don't know my inside angle here, but I do have this little triangle that looks like this. And I'm told that these two angles are 75 degrees. That tells me that this is an isosceles triangle. So I can figure out this measure just from the little angle on the inside. So let's go ahead and figure that measure out. I know 75 degrees plus 75 degrees plus this question mark angle equals 180 degrees. So 150 degrees plus this question mark angle is 180 degrees. So my little question mark angle is 30 degrees. So I'm going to mark that in here, 30 degrees. Well, here's a nice tangent. So I know that it is perpendicular to my triangle. So now I have a nice big right triangle here. So I have 30 degrees plus 90 degrees plus x degrees is 180 degrees. 120 degrees plus x degrees is 180 degrees. So x must equal 60 degrees. Okay, so let's take a look at this one. This one's just a little bit different. I don't know if we'll have time to finish it, but I'll pick it up in the next video if we don't. This one, x is now not an angle measure, but it is a distance. So how are we going to do this? Well, this blue line is my tangent, so I know it is perpendicular. So I can use Pythagorean's theorem to solve this. I know that the length of this side is the sum of x plus 6. So remember, Pythagorean's theorem is a leg squared plus a leg squared equals hypotenuse squared. So Natalie, remember this you have to take into consideration which one is the hypotenuse. So here's a leg here. So I'm going to do x squared plus, here's a leg here because the two legs form the right angle. 10 squared is the hypotenuse squared, x plus 6 squared. Okay, so now we just need to figure this out. 10 squared is 100. When I square this binomial, I'm going to get x squared plus 12x plus 36. So now I'm going to subtract the x squareds from both sides, and that makes it really nice. because my x squareds go away. When I subtract the 36, I get 64 equals 12x. And now I'm going to pause.